6 notes. So now we're on double angles and half angles. So why we're studying this is think about what it means to double something and to take half of something. So if theta is 30, then the double angle would be 60, and if theta were 30, then theta over 2 would be 15. So we are going to use angles that you either multiply by 2 or divide by 2. So we continue our trig chapter with double angle and half angle formulas for sine, cosine, and tangent. So you are going to have to find exact values using each formula, and then there's a double angle formula for identities. So we derive formulas for these. On the notes I had to put a half theta, but that's the same as theta over 2. It's not just a 0. Usually we put parentheses around it. So it is in your notes right here as well as in your packet. The double angle formulas are actually not that bad. Sine of the double angle is 2 sine cosine. The thing that's weird is there are 3 different ones and they are all equivalent. And so sometimes you may want to use this one, sometimes you may want to use this one, and sometimes that one. But they are all equivalent. I'm not going to show they are. You can look at that online about that. And then there's also a double angle formula which looks like this: 2 tan over 1 minus tan squared. So now the ones with the trig function squared are like sine squared, cosine squared, and tan squared. Those have a double angle inside them, and that's getting a little more complicated. And then you have half angle formulas with the trig function squared. Here they're calling A the angle, so the angle over 2, it looks like that. And this one with cosine squared, this one with tan squared. Now the ones that are really, really unique are the ones with half angle that have plus and minus the square root. And again, these are all 3 tan the angle over 2. And this one had a plus and minus, but these did not. I even made a note, there is no plus or minus square root on purpose. Some of these type would actually be really difficult, but I was pretty selective on mine. There were some where you had a nested square root for the first time. It's like that. But since this is high school, I decided not to put those type on there. So some problems are about finding the exact value using double angle formulas, and you're given a fraction in an interval. Some are about identities. We will skip those, but that was when I was doing all the problems by hand. So these are going to be multiple choice, and so you are going to do those. And then some are using identities, and then there's some others. I don't think I actually chose the one with projectile motion, but we could have. And then there's some others. I was very, very selective on this one. Okay, so the first thing is, this is a repeat, the first line and the second line. It's basically just, what is the formula? So you have this cosine double angle, which is cosine squared minus sine squared. And that's the same thing as 2 cosine squared minus 1. and it's also 1 minus 2 sine squared theta. So those are just your formulas. There's 3 different formulas for cosine. Honestly, I couldn't tell you why there are 3 for cosine and not 3 for sine. But I guess we are just dealing with the hand we're dealt. Now the next one is about the sine squared half angle formula. So if you look that up, it'd be 1 minus cosine over 2. And if you're looking at the tan of theta over 2, it's 1 minus cosine over sine. So this time you have to type sine, it's not multiple choice. But those 3 are just formulas. Pretty straightforward. Okay, so continuing with number 4, it's use the half angle formulas to find the exact value of tan pi eighths. So the first clue is it says half angle. So that means you do half of 8, which is 4. So we're going to use the tangent, the angle over 2, and so the angle had to be pi fourths. So you rewrite tan pi eighths as tan pi fourths over 2. Now you use your tangent formula, which was right here, which is kind of convenient. It's 1 minus cosine, and you use the pi fourths, not the pi eighths, and then divide by sine of pi fourths. Again, not pi eighths. So then the next part is you say you have 1 minus, so there's 1 minus. You do cosine of pi fourths like we've done before, which is at cosine of the 45-degree angle, which is the x, and it's square root of 2 over 2, and sine of the same thing, which is also square root of 2 over 2. Now, where you might have trouble is you got to recognize it's a fraction over a fraction. If you ever have a fraction over a fraction, then multiply by whatever this is. And we got lucky in our case that both of them, were the same number. So what that means is multiply all parts by 2. So you do 1 times 2 is 2. Then when you multiply this part by 2, you get rid of your denominator. And same thing for this part, you get rid of your denominator. So what we have is you can simplify your compound numerator, just not if it's a compound denominator. We can split it into 2 over square root of 2, which is the same thing as square root of 2, and minus square root of 2 over 2, square root of 2 over square root of 2, which is 1. So that's how that works. If you needed a little more on that, you could have thought square root of 2 times square root of 2 gives you 2, like that, and then one of them cancels. And so there's your square root of 2 minus 1. So I did make that a multiple choice question, so that's your answer. Now on this one, first off, our function is sine. So if it says f of 2 theta, that means I need sine of 2 theta, which is 2 sine cosine. Before I can even do anything, I have to work with what's given. So I'm given x squared plus y squared is 20. So this is the formula of a circle whose radius is the square root of 20. Which could be broken into square root of 4 times square root of 5, or 2 square root of 5, because we do want to reduce it. Now, since x squared plus y squared is 20, then we replace x with a, and we replace y with 2. So you have a squared plus 2 squared equal 20. 2 squared turns into 4. 20 minus 4 is 16. When you take your square root, you get plus and minus 4. Now, based on where we are, we need to use negative 4 because we're going left 4. Now that we have that, we can then do sine. So sine, as you may remember, is opposite over hypotenuse. So our opposite is 2, and our hypotenuse is 2 over, it's like that. Our hypotenuse is 2 square root of 5. So then you could cancel these and call it 1 over square root of 5 if you want. And for cosine, because we have cosine in the formula, cosine is the adjacent over the hypotenuse, and the adjacent is the one on the x-axis, which is negative 4. So you have negative 4 over 2 square root of 5. Now, the 4 and the 2 cancel, and so you get negative 2 over square root of 5. And so that's this. Now, if you felt more comfortable just typing what we originally had, that's going to be this one that's shaded, 2 times 1 over square root of 5 times negative 2 over square root of 5. And that gives you negative 4/5, which is the right answer. Be careful when you're like putting in your values, because over here I'm showing what would happen if you don't have your divide by sign right. So if you do times square root of 5 instead of divide by square root of 5, then you get negative 20, which doesn't make any sense. And so we need it like this, and that gives us negative 4/5. On the next one, we do it the same way. And so we'd say x squared plus y squared is 17. So r squared is 17. So r is the square root of 17. Now on this one, that doesn't reduce because you can't do 17 divided by 4 or 17 divided by 9. So then our next part is we say x is a and y is 4. X squared plus 4 squared equals 17. Well, that gives me x squared plus 16 equals 17. So x squared is therefore 1, and so we get plus and minus 1. Now, based on, again, being on the left on mine, we need to use negative 1. So this time we have the h variable. Well, the h variable in this problem is tangent. So we have to use our tan double angle formula. So it's not identical to the one above it. You could have sine, cosine, tan, whatever. So we need to look up our tan double angle formula. And that's 2 tan over 1 minus tan squared theta. Now, first off, to the side, what is tangent theta? So tan theta would be the opposite over adjacent. The opposite would be the 4, because it's 4 high, and it's negative 1, so 1 left. So that'd be basically like 4 over negative 1, which is negative 4. Now, also in our formula, it says tan squared. So if we do tan squared theta, that'd be negative 4 squared, which is 16. So let's see how this works out. We want to do a substitution. So tan theta is negative 4, and then we have 1 minus tan squared is 16. So this gives us negative 8 over negative 15. The negatives cancel, and that gives us 8 over 15. Okay, and that is what we want. Okay. Everything else is going to need to be in another video. Hope that's a easy start. These are primarily multiple choice, so you could probably get started on those also. Hope that helps.